So I was discussing about saturation nonlinearity, and I explained the control system with gain block, and I explained that gain as such gain which is actually practically gain can be implemented or realized using operational amplifier, and operational amplifier may be saturated after some time. So uh, saturation kind of characteristics may be present in the operational amplifier. So in the linear system where gain is working as a linear element, then practically if your operational amplifier saturates, then it will exhibit the saturation characteristics or saturation type of nonlinearity. Uh, another common example of saturation nonlinearity is present in transformer. You know that saturation is a relationship between magnetic flux and current in an iron core coil. And iron core coil has linear inductance for low values of current, but if the current increases, the core becomes saturated and the inductance becomes nonlinear. Then there is another example is resistor. A resistor is linear, no doubt about it, because we have seen that resistor, inductor, capacitor are the linear element in the circuit. So we can apply Laplace transform to find out the transfer function. But to an extent, you know, such resistor can also be behaving like a nonlinear element. For low value, actually resistor is linear for low values of current, but becomes nonlinear for higher values of current because of the temperature. You know that temperature may affect the resistance. So there may be not linear, there may not be linear relationship if temperature increases for a resistor. And next we are going to the second type of nonlinearity, which is also comes under uh, incidental nonlinearity, which is dead zone nonlinearity. You know what is dead zone? As its name suggests, that dead zone. There in the characteristics curve, as I've already said, that characteristics curve is always drawn with respect to input and output axis, and x-axis is input axis and y-axis is output axis, and dead zone indicates that the zone must be dead. Now question is that if the zone is along x-axis or y-axis, I mean the zone is along input axis or output axis. Let me draw the diagram at first, and I will explain, and I will give the practical example of dead zone type of nonlinearity. Okay, dead zone. Right. So input output axis are, first of all you have to draw. X-axis is input and y-axis is output, right? Let me fix the camera problem. Okay, now it's not. So I mean that you are applying input, we should get output. Now the thing is that you are applying input, but you are not getting output. You are applying input in the positive side as well, and also in the negative side. Positive input axis, negative input axis. But you are applying input, but you are applying positive input, you are not getting output. Positive output, you are applying negative input, and you are not getting negative output. So how does it look like? So maybe I can draw this curve, and you see that what is this actually? This is the input axis. So input is increased, right? Input is increased. I am increasing my input to the system, and up to that point the input is increased but no output at all up to that point. And after that point, you are also increasing the input, you are getting the output. You are increasing your input, you are getting the output. You are increasing the input, you are getting the output. And the same thing happens in the negative side as well. So, so what is the dead zone? The zone is this. Why it is called dead zone? Say it is plus D and this is minus D. Dead zone means you have applied the input but you are not getting the output. The output is dead in this zone of input. So that's why it's called dead zone. And it may happen, this is practical life. In our practical life, when you open your shower in your bathroom, what will happen that you will rotate the knob of the shower, and after some time you are actually rotating, and that means you are applying the input, but the water is not coming out of the shower. That means that you are applying input, you are not getting the output. This is the actually shower. Inside the shower is nothing. The knob is nothing but a valve. The water valve. Now water valve is also a component in engineering system. Actually water valve, you are using water valve. Actually this water valve is manually operated, but in industry, everywhere where flow control system occurs, where pressure control system occurs, the valve generally uh, operates automatically. Okay, and the valves are motorized valve, and that means that motor is rotated to rotate the shaft of the valve, and the valve is rotated but no flow of water. That means that you are not getting the output. You are applying input, you are not getting the output. So this the dead zone type of characteristics or nonlinearity may be present in the valve also. And for electrical system, you have seen in your measurement laboratory that galvanometer, you have seen that the pointer of the galvanometer or ammeter, okay, you are applying, actually the current is passing through the ammeter, or there is also a voltage applied to the voltmeter, but the input, the current, if I consider only one example at a time, say if I consider the example of ammeter, then what will happen for the ammeter? The current is flowing, the current is the input in this case, but the pointer is not moving. But pointer may not move due to the problem in the coil, but I don't know the problem of the coil, but the point is that pointer is not moving, and the pointer deflection in this case may be considered as output, whereas the current in this case may be considered as input. So you are applying the current, but after some time, if some value of current, say 0.5 ampere up to 0.1 ampere, there is no movement of the pointer. Then after say for zero point 0.2 ampere of current, then the pointer moves. So I can say that up to 0.1, plus zero point 0.1, if it is a ammeter for AC ammeter, then for for point plus 0.1 ampere to minus 0.1 ampere, there is no out to pointer deflection. So that means that the zone is dead for this range of input. After 0.1 ampere, then point ampere is increased from 0.1 greater than point, which is greater than 0.1, the 0.1 to 0.132. When it is increased, then the pointer starts deflecting. This is called the dead zone type of characteristics, which may be present in the galvanometer, ammeter, or voltmeter. So these are the practical problem and the practical nonlinearities we have to deal in our engineering system. So in case of petrochemical plant, in case of hydroelectric systems, pneumatic systems, this kind of knowledge, we have to deal with this kind of nonlinearity. And whenever the nonlinearity is present, you know that the differential equation is not linear differential equation, and so in this case you cannot find out transfer function, you cannot find out stability determination using both the Nyquist plots. So next we are going to the third point of incidental nonlinearity, which is Coulomb friction. Now friction, you know that friction is a force which basically oppose the motion whenever there is a sliding contact between mechanical surfaces. Now, if the force is linear, then it's called viscous friction. Uh, I will draw the diagram, and basically, the actually friction has various components. Friction is a force. I want to mean, and it has various components. Let me draw the diagram of viscous friction and the Coulomb friction. What is the difference between the viscous friction and Coulomb friction? Now, whenever I draw the different types of nonlinearity, or whenever I draw the characteristics curve, I must draw the input-output axis first of all. Now, in this case, if I consider friction, then input may be considered as velocity and output is force. So, frictional force, what is frictional force oppose the motion whenever there is a sliding contact between mechanical surfaces. So if there are two blocks which are moving along their surfaces, there must be a friction force. uh, there are various parts, there are various components of friction force. Number one is viscous friction. Now, viscous friction is linear in nature, because viscous friction, if I draw the curve of viscous friction, it looks like this. And if I write down the equation of viscous friction, then if F is the force which is output, then it is Fx Fv. The V is the velocity and F is the slope of the curve, small f. However, capital F is the denotes force which is output, and V is the velocity which is input in this case. So viscous friction is a linear characteristics. But in addition to the viscous friction, there are two nonlinear frictions as well, which is called as Coulomb friction. Now, what is Coulomb friction? Coulomb friction is basically a constant retarding force, I mean opposing force. And you know that whenever you try to move any block from the surface, on the surface, uh, it will restrict. You know, there must be a restriction between the surface of the block and the surface of the uh, uh, surface, whatever surface of, say the block is placed on the table. Then there is a two contacts surfaces. One, the surface of the uh, bottom of the block, and the top of the table. Now, whenever you try to move the block on the table, there must be opposing force. Now, thing is that when you try to move the block, initially the force required to move the block is high. Then when it gains the motion, the force required is not so high as compared to the initial force required. So the initial force in this case is called as stiction force, which is always high. You know, if I draw the diagram, then you will understand better. Always remember, the input is x-axis is input, and in this case input is velocity and output is force. As I have said to you that when you try to initially, there is a larger force required. initially. So at the point of, or at that point of origin, there in the characteristics curve, what is happen, what will require, the force is required, the force required to initiate the motion is high. Then when it gains the motion, I mean when the velocity is increased, then the force required is less. So I may draw the like say up to that point the initial force, and then this is the constant retarding force or opposing force. So if I draw the negative characteristics, this is also true for the negative characteristics. So this is the stiction force, and this is called Coulomb friction force. But I have drawn this diagram, actually is very straightforward. But practically, this is the ideal characteristics curve. But practically, what will happen? Practically, you know, let me draw the axis again, which is input axis, and this is output axis, and practically, stiction force is high, always high, and just not like discrete like figure, it will catch the constant returning force, which is Coulomb friction force, gradually. So it must look like this. Now this initial high force is called stiction force, and then a constant returning force is called Coulomb friction force. Now as a whole, this figure, if you see the figure, this figure is not linear, it's not representing the straight line. However, the viscous friction was straight line, but viscous friction is one part of the force, friction force between the two sliding surface. The Coulomb friction force is another part, another part of friction force, frictional force, and Coulomb friction force, which is actually to initiate before the Coulomb friction force uh, happens, there is an initial force which is called stiction force. So this stiction force and Coulomb friction force as a whole, this characteristics curve is called as stiction with Coulomb friction force. And see, this curve is however it is linear, but these two curves are not linear curve. This is no more linear, so completely non-linear characteristics curve. So this is called Coulomb friction force, which is also another type of non-linearity. Now whenever why is it required, what is the source, you know that for say inverted pendulum problem, say inverted pendulum problem is a kind of problem where a stick is hold upward, okay, on the on a rail. There is a moving body which has a maybe which may have a wheel, and it may move and move up left and right, and it will hold, but it may however the block will on the wheel move left and right, but the stick will be actually fixed, as stick will be fixed as a straight line on the block. So this kind of in this kind of problem, even for where if you want to design a in case of CNC machine also, and in case of printer also, there are moving surfaces between various wheels to move the roller to print the sheet, or say in case of also paper mill also, there are various rollers which are actually touched by their surfaces, so there may be this kind of force. And if you want to design your control system for these kind of problems, you have to deal with this Coulomb friction force and stiction force, but you cannot have transfer function because of this kind of nonlinearity. So what to do, is to find out the Descartes function. However, I have not started explaining that what is Descartes function, but let me tell you, the Descartes function is the method which is basically used to represent this kind of nonlinearity. And if you have representation of nonlinear system, you can now find out the stability, and you can design your control system accordingly. So next, incidental. These are no incidental nonlinearity. Again, I am talking about incidental nonlinearity. What is incidental nonlinearity? Incidental nonlinearity is that this kind of characteristics or nonlinear characteristics which are present inherently in the system. So this is not intentionally made. It is inherently present. In case of sliding surfaces, uh, the motion is initiated, there is a Coulomb friction, there is a stiction force. So these are the nonlinearities which are inherently present. That's about incidental nonlinearity. Then we are moving to backlash nonlinearity. Now I have already attached the notes on various types of nonlinearity in my Google Classroom. There is a very good figure. You can check my notes. Here I am not drawing the good figure, because in backlash basically present in gear trains, when there are two gears are connected by each other, there may be backlash nonlinearity. Mm. Now question is that what is backlash nonlinearity? Backlash nonlinearity is a mechanical hysteresis, I can say. You can remember the characteristics of hysteresis curve between input output axis. Now I can refer the diagram to my notes which is attached in Google Classroom, but I want to just discuss about the characteristics curve. So first of all, I am drawing the input output characteristics axis. Now say I am drawing just the gear of uh, I have to draw the two I have to draw two gear, but you can see my note for the figure. However, this figure is not looking so good. You can check my note. What is my point is that, say this is gear number A, and this is gear number B. Now it has teeth. This A gear is also having some teeth, and the B gear is also having some teeth. Now the teeth of the B gear is in between the two teeth of the A gear. Very carefully see the figure. The teeth of this teeth of the B gear is in between the two teeth of the A gear. Now what happens? Now initially say the teeth of the B gear is in the middle position, or exactly at the middle of the two teeth of the two gear. Now there is a gap. There is a very small gap in this side and in this side as well. Okay, in this side and in this side as well. Let me just assume this distance, but the distance between this teeth and this teeth is this is say b by 2, and also this b by 2. Okay, this is b by 2 and this is also b by 2. Okay, the distance between this teeth and this teeth, and also since that this teeth of the b gear is exactly at the middle of the between the two teeth of the a gear, so the distance here also, if it is b by 2, then it is also b by 2. Now suppose if I draw suppose this a gear will try to move the b gear. So find out my input and output. What is my input? Now any movement of the a gear say denotes it is theta I, theta input, and the theta, if I want to move the a gear in the clockwise direction, what will happen? What will happen? The b gear will also try to rotate. Now the b, if this a gear rotates in this direction, then what will the direction of the b gear? This side, this direction. Suppose this is theta o. So if I want to rotate the b gear by theta o, then I have to move the a gear by theta I. So I can consider the input in this case is theta I and output is theta o. But before the b gear moves, there is a gap. You see, there is a gap. So a gear has to move at least b by 2 distance to move the b gear, because initially the b gear was exactly at the middle between the teeth of the a gear. Now for the movement of the b gear, okay, for the movement of the b gear, the a gear has to touch the teeth of the a gear, has to touch the b gear this side, that side. Now for the to touch the b gear that side, the a gear must have to move by b by 2 distance. Now b by 2 is the b by 2 movement means along theta I, which is the input in this case initially. So initially the input is b by 2, but still before b by 2 there is no movement of b gear. মানে a গিয়ারটা ধাক্কা মারার আগে b গিয়ার কিন্তু মুভ করছে না। a গিয়ার b গিয়ারকে ধাক্কা তখনই মারবে যখন b by 2 ডিসটেন্স কভার হয়ে যাচ্ছে। তো দ্যাটস ওয়াই you are applying input but you are not getting output. So you are applying the input b by 2 along theta I, but you are not getting theta o. Then when it will touch the after covering b by 2 distance, when it will when the teeth of that side a gear will touch the b gear teeth, then the b gear will try to rotate in this direction, okay, which is theta o. Now this theta o will increase as long as the a gear is rotated in this direction. So that's why, and this increase of theta o will be linear. Now this is uh, the up to that point it is okay, I think. Now suppose the a gear is now moving in the backward direction, okay, a gear is trying to move in the backward direction. If a gear moves in the backward direction in this direction, then the b gear also try to move in this direction. Kintu, but there is a touch, and when that side of the A teeth will touch that side of the B teeth, then this B by 2 is there is no B by 2 distance there, it has touched. Okay, so now if it is touched, then this overall gap is now becomes B by 2 plus B by 2, which is B. Now if I want to move this B gear in the opposite direction, I have to move the A gear in the opposite direction. Now opposite direction will happen only that time when that side of the B gear A gear will touch the B gear teeth. Now it the A gear that's for the A gear teeth, that side has to cover has to move B by 2 B by 2 B by 2 plus B by 2, at least B distance for the touch. So now also the output is now angle output is theta O is now at that point is fixed. Now for the reverse direction, it has to travel at least B by 2 plus B by 2. That means B. Now at that point it is B, the C along B axis B by 2 plus B by 2, it has traveled B by total B distance. Now it is, if it is going the opposite direction, the the B gear also moving in the opposite direction. That's why again see theta is now again changing. Now if I consider the negative characteristics, then it will be, the characteristics curve looks like this. So the direction of rotation should be, it is forming a loop. It's called mechanical hysteresis. Now this kind of nonlinearity is called backlash nonlinearity, which is present in the gear trends, gear system. And you know that gear systems are all everywhere it is present in robotic system or electric vehicle, wherever gears are present, there may be you can expect backlash kind of nonlinearity in the system. And in the, if you consider the backlash nonlinearity, then it is and generally gears are required for the after gears are actually fitted after the motor shaft. So if you want to design a control system for the motor, then you have to take care of the backlash nonlinearity. In such case, since the backlash nonlinearity is not linear system, so you have to carefully model your differential equation or differential equation representation for the motor system, considering the backlash nonlinearity. And another important point I want to say, that backlash nonlinearity is also called as memory type of nonlinearity. It is not memory-less nonlinearity. What is memory type and memory-less? Memory type of nonlinearity means that it the shape of the history, the output depends, the for memory type of nonlinearity, the output depends on the input. I mean, say how much it has traveled, and how much that means theta o, how much theta o is how much angle the B gear has traveled. Say it is theta o1. So initially if it was theta o1, then it is theta o1. For theta o1, that was the shape of the hysteresis curve. Say for my next experiment, my angle of rotation of theta o, say is less, say it is theta o2. So in this case also my output of the hysteresis nonlinearity is now changed, so the loop is now changed. So this kind of nonlinear output basically depends on the input and it requires the previous input. That's why it's also called as memory type of nonlinearity. But in such cases of dead zone, saturation, and Coulomb friction, it doesn't require the previous value of the input. So the shape is always same for all the cases. Whenever you do the experiment to find out the characteristics curve, you will find out the same characteristics curve again and again. So this is called, this type of nonlinearities are called as memoryless nonlinearity. Now we have covered these different types of nonlinearity. We hope that we have understood this concepts of and characteristics of and presence of nonlinearity. Next, we are moving to the next type of nonlinearity, which is called intentional nonlinearity, which is relay. Now, relay, you have heard about that current relay, voltage relay, current sensitive relay, frequency sensitive relay, over current relay, over voltage relay. I'm talking about electromagnetic relay, electromagnetic attraction relay, to explain the incidental nonlinearity. Uh, electromagnetic attraction relay, I have one electromagnetic attraction relay. This is called electromagnetic attraction relay. Now this is the relay where you can find out the characteristics of relay. Relay nonlinearity. Now what is, before I discuss about intentional nonlinearity, I will first of all draw the characteristics curve of relay nonlinearity. Relay, there are also various types of relay nonlinearity. Let me draw one by one. Now relay nonlinearity basically on-off type nonlinearity. Why relay is used? Relay is used in a robotics, for in refrigerator. You have seen the sound of refrigerator, that when the refrigerator is sometimes it is on and sometimes it is off. Those you may hear a sound from the refrigerator that it is on for now and then it is off. There is a thermostat and which senses the temperature inside the refrigerator. There is a set temperature. When the temperature of the refrigerator is below the set temperature, the compressor is on. and when that inside temperature of the refrigerator is above the set temperature, the compressor is off. The on and off operation is done by the relay. Relay is a nonlinear relay is a nonlinear device. No, not device, a nonlinear element, I can say. Because refrigerator, maybe I can say refrigerator is a device, and in the refrigerator, no, relay is used as a component in the control system. Also, we have seen that sometimes automatic control system that requires that when the input is achieved, when the input is there may be a condition that when the input is this, then output is on. When the input is this, the output is off. So if I see the first figure, you see the first figure, the x-axis is input and y-axis is the output. And what is the condition for the characteristics curve? When the input is just greater than 0, the output is on, and when the input is just less than 0, the output is on but the negative side. So I mean that so this is the 0, this is the 0, this is the origin. So if the input is just greater than 0, the output is on. When the input is just less than 0, the output is also on by the negative side. Now when output is on, say the magnitude of the y-axis is m, so say it is m, so say I can say that output is equals to m when input is greater than 0, and also output is equals to minus m when input less than 0. So this is a mathematical representation of the nonlinear of the on-off type of nonlinearity, and this kind of characteristics are you can expect in the relay. Okay. Now thing is that practically it doesn't happen, because relay, if you if I con the if I am able to conduct the real class, I may explain better. In my virtual class, it is not possible to explain the working principle of relay. uh, Basically relay, you see, the relay has a coil, you can see it's electromagnetic, it attraction relay, and relay has a coil. Now, what is the purpose of the relay? Relay is a purpose that the coil is energized from the microprocessor or microcontroller, such that when the control signal is say this is signal, the relay coil energizing current is is my input. Say when what happens that relay when actually relay coil is very small, you see, you can relay coil is very small, and relay coil may be energized from the microprocessor pin. Now microprocessor pin, you know that microprocessor pin generally produce 5 volt to 5 volt and with few milliampere of current. So to energize this coil, very few milliampere is required. So small coil is very small in size. Now coil may be energized, but there is a plate, there is maybe a plunger kind of uh, uh, construction and plate inside the relay, that what will happen when the relay coil is energized, it will attract a plate such that two contacts which are initially open now closed, becomes closed. So what will happen that when the input, that is when the input is just greater than 0, that means when the relay coil is energized, the output is on, মানে এই রিলেটাকে দিয়ে যদি এই রিলেতে অনেকগুলো টার্মিনাল আছে, তোমার দেখাতে পাচ্ছি না এখন, রিলেতে অনেকগুলো টার্মিনাল আছে। ইনিশিয়ালি তোমার ধরো 230 ভোল্টের সাপ্লাই এখানে কানেক্টেড করা আছে, একটা সাইডে দুটো সাইড দুদিক থেকে দুরকম ভাবে কন্ট্যাক্ট যাচ্ছে, প্যারালাল। তো একটা সাইডে এই দুটো সাইড, সাপোজ this side, say এখানে যে this pin and this pin, you can connect your 230 volt supply. So this is the phase and this is the neutral. 230 volt AC are connected, and this side your bulb is connected. Okay, your bulb, say bulb may be a 230 volt 60 watt bulb, so bulb is connected. Initially these two contacts are open, so there is no current flowing between these two contacts, so bulb is initially off. But when the relay coil is energized, it will attract the inside plate such that these contacts are closed. So 230 volt is now connected to is directly connected to the bulb. Now bulb is on. The bulb will glow. So that is the operation of the relay. So for purpose of on off relay, in case of in case of, say, in case of a motor, you can also connect a motor here, and when the motor initially off, when the relay coil is energized, the motor is on. The motor may be operated with say 400 volt. You can connect your 400 volt DC supply in this case, if your relay is AC relay, and motor is connected to these terminals, but the relay coil requires a very small amount of current to energize it. So relay, in this case, relay coil current required for activating, for energizing the relay coil is the input, and output is my output, that which will the passed for the load. So I've tried to explain the concept of relay here. However, you may, if you find out problem for understanding the relay, you cannot find out this explanation in your conventional books. If when the college reopens, I can explain once again if you have problems understanding the actual concept of relay. Now, thing is that one point I want to make it very clear to you, that the relay is a relay relay as a coil, and the coil requires coil requires the current for energizing, and that is the input axis, and output is the load, value of the load. I mean the voltage and current of the load, voltage or current of the load. Now relay coil, suppose I have a 5 volt relay, and that means the relay coil requires 5 volt to be energized. Now suppose you have a variable DC supply, that means you can generate 5 volt gradually. Say I can also apply 1 volt to the relay coil, 2 volt to the relay coil, and 3 volt to the relay coil, and 5 volt to the relay coil. But any relay coil requires a specific amount of voltage and current. You see, suppose if you 5 volt relay coil, if you apply a 2 volt relay coil, you do not expect the relay coil is energized. Okay. However, if you go to close to 4.5 or 4.9, close to 5 volt, then it will be energized. It doesn't mean that a 5 volt relay requires exactly 5 volt supply. Okay, it may be energized with 4.5 volt or 4.2 volt, but it requires a specific amount of voltage to be energized. For this reason, if you see the second figure, that suppose I am applying 1 volt, 2 volt to the relay coil, that means you are applying input, as I've already said to you, and I have made it clear to you that the input axis in this case, in the characteristics curve, denotes the relay coil current or voltage. So if you are applying 1 voltage, 2 voltage, 3 voltage, you do not expect the relay is on. Relay will become on. So you cannot expect the output to be on. However, you have applied 1 volt, 2 volt, or 3 volt. That's why I can also expect a dead zone here. So you are applying 1 volt, 2 volt, 3 volt to the relay coil, you are not getting the output. But after some time, say if it is 4.5 or 5 volt, it is suddenly on. So this is on off with dead zone. It is kind of characteristics curve is called on off with dead zone, and which is also present in the relay. Uh, Next, if I go to the next figure, it's a it looks like hysteresis, because relay also exhibit hysteresis kind of characteristics. How say your relay is now, if you see my figure, you see the relay is initially relay requires a specific amount of current. Now relay is on. Now you see again when the relay is on at that point. Now again if your relay energizing coil is connected to variable voltage supply. Now you decrease your variable voltage supply. Say when suppose it is on at 5 volt, now you decrease from 5 volt to say 4 volt, 3 volt, 2 volt. So after some times you can expect that kind of figure. See when it is 5 volt at that point, when you decrease 5 volt to 4 volt, 3 volt, 2 volt, it is still on. But when it is going to negative side, and you are applying negative voltage, then it is suddenly off. So thus it is forming a loop. Better it will you will understand this figure, this hysteresis loop from this figure. You see, first of all, you track my sketch pen. Initially, you are applying 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. Now, suppose your relay is 5 volt, it requires 5 volt to be energized. So, you are applying 1 volt, 2 volt, 3 volt, 4 volt, but still that is not the on point. See, still you are not getting your output. At that point, the relay is on, and suddenly you are getting the output. It is on. Now, when it is on, it is on. Still, if you increase your if you still increase your input, it is always on. Okay. You track my sketch pen. Once again, I am repeating my explanation. I am applying my input gradually from 1 volt. However, the relay requires 5 volt to be energized. I am gradually increasing the voltage to the energizing coil of the relay. Say it is one, I have applied 1 volt, 2 volt. So obviously there is no energizing of the relay coil. So I'm still increasing the voltage to the energizing coil. At 5 volt, the relay is now on. The energy coil is energized. The relay is on. And after that point, if you still increase the input, it stays on. Now, if you decrease the voltage from 5 volts, say 5 volt to 4 volt to 3 volt, 4 volt, 4.5 volt, 4 volt, up to that point, the relay coil is now energized. Say, এটা অবশ্যই হবে যে 5 ভোল্ট থেকে 4.9 বা 4.8 আসলেই যে রিলে কয়েল de-energize হয়ে যাবে তা হবে না. So that point, say up to 4.7 volt, it is all still energized. So the output is still on. But after when a 5 volt relay means requires 5, not exactly 5 volt, may requires 4.5 volts. কিন্তু কখনোই না that it will operate at 3.5 volts. Say now I am again decreasing my voltage, and after at say it is the 3.8 volt. At 3.8 volt, it cannot attract the plate inside the coil. The coil is not no more energized. So suddenly the output is off. Now again, if you still increase the voltage towards 5 volt, it is on. If you again decrease your voltage, it is again off. So it is forming a loop, hysteresis loop. And this is true for the positive case. This is also true for the negative case. So this kind of characteristics is called as relay with dead zone, on-off with dead zone with hysteresis. The first figure is only on-off characteristics curve. It is called on-off relay. Relay with on-off type of nonlinearity. This is called on-off with dead zone. This is called only hysteresis. This is called on-off with dead zone with hysteresis. So this kind of characteristics graphs basically present in the relay nonlinearity, and you see this is called intentional nonlinearity because you can get this kind of characteristics graph intentionally by applying voltage, by increasing voltage or decreasing voltage. So this is not it is not incidental in this case. It is intentional. You try to understand, you try to visualize what I am trying to explain here. I know that these explanations are not you cannot find out this explanation in the book. When I was a student, I was also having some problem to understand how the source of the figure of characteristics curve. I didn't understand at that time, so I searched various books. Somehow, fortunately, understood that what is the how does it how is the working of that characteristics curve. So try to understand by playing my video again and again. Still, if you have any doubts, you can put your doubts in the comment section of the Google Classroom. I can address your doubts in the next online class, my online class in Zoom. So far we have covered the various types of nonlinearities, various characteristics curves of different types of nonlinearities, and what is the reason of this kind of characteristics curve, and what is the source and what is the example I have covered elaborately regarding the different types of nonlinearity. Next we are going to my next topic, which is describing function method, in my next video.